I'm going to solve the final examination questions. And in recit exam, there will be very similar questions will come. Okay, so please pay attention and try to understand. I don't know if more students will attend, but I will start because I am sick. I can't wait so much. Okay. In the first question, please listen carefully and ask me if you don't understand. So, in the first question, we are going to estimate the CPU utilization according to the given information below. We did this kind of questions before. Okay. So the look, process size and memory size. Memory size the total size of the memory. Okay, and process size is the coming process size, which it means roughly if each process is 8 megabytes and our memory size is 16 megabyte, it means we can fit two processes into the memory. Okay, and we have input output time 50%. So we have a formula. I'm going to write as U. CPU utilization 1 minus P over N. So N is how many process we can fit into the memory. So it will be 16 over 2, which it will be 2. Okay, so N is 2. P is input output time. It means how much time we are going to waste in input output. So that's why we are going to subtract it from 1, because if input output time is 30%, it means 70% of the time is using by the CPU. So because of we are going to calculate the CPU utilization, we will subtract it from 1. So this can be written for the formula as 0.5. Okay. So when we put all of them in the formula, it will be 1 minus 0.5 over 2. So actually, it doesn't need this. So so this will be 0.25, the square of 0.5. So 1 minus 0.25 will be 75, 0.75. So it means the utilization of the memory is 75%. Okay, so we can find the utilization like that. Do you have question about this? We are going.
No, sir.
Hello.
Yes,
Okay. Is it okay?
yes, sir. It's okay. We don't have question.
Okay. So let's continue. What about the second one? In second one, I just write the same thing verbally. Most of the students mix it. I am saying in the above scenario, what happens to CPU utilization if memory size increases to 24 megabytes? So instead of, can you mute the voice, please?
Yok okuyor. Hafif mi yoksa? Kolay.
Okay. So in the second one, the process size will be same, 8 megabytes. But memory size increased to 24 megabytes. So input output time is same. Is same. So 50%. So if I can say that to put the formula, I can make it as 0.5. So for the formula, same thing like this. I mean, I will apply this formula. So utilization is equal to 1 minus, this time, what is P? P is 24 over 8. So it will be, what is N? 24 over 3. So 2. Here I made the mistake, by the way. This is 8, sorry. 24 over 3, 24 over 8 is 3. So P is 0.5, so same. 0.5 over, I mean, cube of 0.5 should be 1 second. 1 minus 0.125. Okay. So in the exam, some students may be not able to make it without a calculator. If you keep it like that, I gave full mark. Okay, so actually I need this formula. So the rest of them are mathematical calculation. So if you are not able to do it, you can keep it like that, and I will not cut points. So 1 minus 0.125 is 0.875, which it means, let me to write 87.5%. So this is the utilization. Okay. So two questions are same actually. Just one of them is I wrote verbally, so maybe some students are confused like this. Okay, this question is okay. Okay, no answer. I think it is okay.
Yeah, it's okay.
Okay. Let's come to the second question. In the question, we discussed the memory partitions, fixed partition, dynamic partition, linked list method. So I mean, by checking the sentence, you have to understand what kind of partition is this. So in the question, it is saying assume that the memory is 30 megabytes with 6 partitions, that is 5 megabytes for each. So it is saying that in the memory we have 6 partitions and each of them is 5 megabytes. So this is fixed partition. Why? If you remember from the lectures, in fixed partition, in the beginning, memory is creating a fixed partition size. Okay, this is not a must to be equal all partitions, but the partition size are fixed, which means when it is created, it cannot be changed later. So when we are asking what kind of partition is this, it is fixed partition. You understood why we are saying it is fixed partition? I can show you the difference from the sentence. Let me to erase this one. No. Okay. I showed why it is. Anyway. Look, in fixed partition, when think about that, you started your computer, okay? Also, fixed partition is an old technology, actually, not today's technology. But I told in the class, to come to today's technology, we have to know how they change it, how they modify it. In fixed partition, let's say you open your computer and in the beginning, operating system is creating partitions for the memory, because now we don't need to make partitions. We can put all the programs in one place. But in the beginning, we were putting only one process in the memory. Then when multi-programming comes, they started to put more than one process. So this is a problem occurred after the operating system and the technology is able to put more than one process into the memory at the same time. So to keep them separate, operating system is creating partitions to the memory. Okay, it depends to the system that they are using. Let's say here our memory is 30 megabytes, and we know that the processes is about 3 or 4 or 5 megabytes that are coming. So to fit that processes, we made 6 partitions with 5 megabytes for each. So this is fixed partition because we are creating it in the beginning. Okay, we don't know the process size. We just create it and we wait for the processes. Okay, that's why it is fixed partition. But look, in the fourth question, part D, in the same scenario, if the partition size is declared according to the process size, guess the partition type of the system. This is dynamic partition because operating system is just creating a partition when a process comes. If 3 megabyte of process coming to the memory, it is creating a 3 megabyte partition. Okay, if 5 megabyte comes, it will create 5 megabyte partition. So this is dynamic. Okay, and the first one is fixed. That is the difference. I hope you got the point. So this is fixed partition. So let's say, what was our memory? Let's draw a table to simulate. Let's say this is our memory. And each of them is, this is 5, I can't write here. Each one is 5 megabytes. Why? Because it is saying in the question, 30 megabyte with 6 partitions. Okay. So let's say, so each of them is 5 megabytes. Okay. Each of them is 5 megabytes. Then it is saying calculate internal and external fragmentation if some processes try to load into the memory with 3 megabyte, 4 megabyte, 3 megabyte, 2, 4, and 5 megabytes. So these processes are coming to the memory. Okay. If 3 megabytes of process are coming. Let's say it is 3 megabytes. Our partition size is 5. So it will use the 3 megabytes of the memory of that partition and 2 megabytes here will be unused. Okay, so let's say okay, in first partition, 3 megabytes of the partition will be used and 2 megabytes will be unused. Then it is saying the second is 4 megabytes. So we will have 4 megabytes of process is coming to the second partition. So here we have 4 megabytes of memory used and 1 megabyte will be unused. It will be empty, in other words. Then 3 megabyte will come, 2 megabyte, 4 megabyte, 5 megabytes. So let's say for 3 megabytes again, three megabytes will be used by the process and 2 megabyte will be empty, and it goes like that. Okay. So it is say calculate the internal and external fragmentation. How we calculate the internal fragmentation? Internal fragmentation is the fragmentation of each partition. Okay. What is fragmentation? Fragmentation is the unused part of the memory partition. Okay, so if you check the first one, the 3 megabyte of memory process comes to the partition, but the other 2 megabytes will be useless. Okay, we can't put any other process there, so it will be a kind of wasted part. So in internal fragmentation, we will calculate the wasted partition parts one by one. Okay, so for the first one, we can call it partition 1. So can you tell me the fragmentation of partition 1? Who can tell me? Fragmentation of partition 1.
5.
No, this is the partition size. 5 is our partition size. What is the fragmentation? Fragmentation is 5 minus process size. 5 minus 3. What is partition 1 fragmentation? Internal fragmentation is 2. Yes. Okay. Now we are calculating the internal fragmentation. Internal fragmentation is we are going to put them one by one. You can say like that, by the way, 5 minus 3. is 2. So let's say that. For partition 2, can you tell me partition 2 fragmentation, internal fragmentation?
5 minus 4.
Yes, it is 1. Yes. Okay, so it goes like that. Partition 3 will be again 2. Partition 4 is 5 minus 2. It will be 3. Partition 5 you can record, but I am already recording the lecture. Okay, no problem. Partition 5 minus
Is
4.
1.
5 minus 4 is 1. Yes. And partition, what
Yes.
about partition 6?
0.
Yes, it will be 0. 5 minus 5 is 0. Okay. So this is internal fragmentation. But it is asking us the external fragmentation as well. External fragmentation is the addition of these partitions. Okay. So you can say like that. External fragmentation is 2 plus 1 plus 2 plus 3 plus 1 plus, let's say, to know it 0. I know there is no effect. So it will be 5, 8, 9 megabytes, I think. Okay. Okay, this is the answer of the question, and question type will be similar. Is this one okay? External fragmentation. Let me to say what is external.
Yes.
External fragmentation is the total fragmentation of all partitions. Okay. So internal is just we can calculate it for each partition. But external for all the partitions. Yes, any question for this? Okay, I assume that it is understood. Okay, I will continue. Ah, sorry, let's make it undo. I hope this works. Ah, okay. So the next question saying what happens if the last coming process is not 5 megabytes, it is 6 megabytes. So it was 5 megabyte before the coming process. What will happen if it is 6 megabytes? And try to enter to the 5 megabyte of partition. Do you have any guess what will happen? Last process is not 6 megabytes, 5 megabytes. We change it to 6. Yes. Where user is answering all the questions. So it will not fit there, okay? Because of it is fixed partition, it cannot fit here. Okay, so let's go to this question I am saying. If the last process is changed from 5 to 6. So you can say because of okay, because of the coming memory, coming process is bigger than the partition size, so it will not fit to the memory, okay? Because all partitions are 5 megabytes, so my coming process is 6 megabytes, so it can't fit to the memory. Okay, if there is any misunderstanding part, please warn me to stop. So in the same scenario, if the partition size is declared according to the process size, guess the partition type of the system. So in part T, this means that we are not creating the partition size in the beginning. We are waiting to a process to come, and we will create the partition after that. So this is called dynamic partition. Okay, this is the answer of the fourth part. So we have a similar question, partition question, but this this time we will use dynamic partition to solve it in part E. Okay. Let's add the same table. Okay, we are in same scenario, but this time partition size is declared according to the process size. By the way, actually, I have to erase this table. This is, I answered this. I will answer it for this question. Okay, so we have a memory, okay? And in the beginning, there is no partition because it is dynamic partition. First, 3 megabytes of memory, 3 megabytes of process is coming into the memory. Okay. Operating system will see this and reserve a space of 3 megabytes of partition. Okay, so this will exactly fit to this place. Okay, so here our memory, our process will be here with 3 megabytes. Okay, do not confuse. This 3 megabyte is partition size. This 3 is the process. Okay, both of them are same, but do not confuse it. The second one, 4 megabyte of process comes. 4 megabytes. So operating system will reserve a 4 megabyte of partition. Okay, so the partition size will be 4 megabytes. Process size will be 4 megabytes. So it will go like that. Okay, for all the processes. So while we need to calculate the internal and external fragmentation in this situation, it will be 0. Why? Because when we calculate internal fragmentation from partition 1 is 0. Partition 2 is 0. Can you tell me why it is 0 before continue? All partitions will be 0. Why?
Because 3 minus 3 equals 0, 4 minus 4 equals 0.
Yes, yes, this is a good, this is a kind of robotic answer, but it is correct. You can say as well, the memory size and the process size is exactly same. So that's why it is 0. Your answer is correct. It is a kind of algorithmic answer. Yes, so internal fragmentation is all 0. So if the internal fragmentation is 0, external fragmentation will be 0 again, because it is the addition of all partitions fragmentation. So external fragmentation will be 0 again. Okay, it's because I am adding all internal fragmentations to find the external fragmentation. So is this one okay? By the way, I will quit from the lecture and open again because I have only 1 minute.
Okay.
So let me to finish it and then continue.